Hey everyone, this is Daniel for Rock the JVM, and you are watching Full Stack Scala 3 with the Typelevel stack. It's so nice to speak to an actual live audience instead of a screen for a change. So it's so nice to see you. Thank you for coming to my talk on Full Stack Scala 3 with the Typelevel stack. How many of you have heard of Rock the JVM? Just raise your hands. This is the most heartwarming view that I've seen all day. Thank you. So for those of you who don't know me, I am Daniel. I founded this little website called Rock the JVM, which is a learning platform for pretty much everything in the Scala world. I'm a Scala developer and instructor for more than 8 years now. And my online training material has reached more than 80,000 people in all over the world, basically. And I teach pretty much everything in the Scala world, and I'm going to show you something about a little learning experience that I've created. This is my biggest project yet, and has multiple facets. If you want to reach out to me, I am active at Rock the JVM on all socials. I'm most active on Twitter and LinkedIn and YouTube for some reason. So if you want to reach out to me, just go on Twitter and LinkedIn, on YouTube at Rock the JVM, or just send me an email at daniel@rockthejvm.com. I am more than happy to help with anything Scala related. So yeah, I made an app. This is a jobs platform that I made for myself. So I created this little full stack application that I will personally use for my audience and for my private community at Rock the JVM. So if you're a company, you can go to jobs.rockthejvm.com. It's live. I launched it like 3 days ago. So if you're a company here at Scala, or if you want to advertise your open positions, just post your jobs there. It works. Just create an account, post your jobs, and I will personally promote them to my private community at Rock the JVM. It's completely free, although the app has a support for credit card checkout, but I've turned that off, so the paywall is off. You can do that for free, and it just works. I promise I will advertise you to my private community. This app has a lot of features that you would expect from a full-blown product. So it has the regular CRUD that you know from full-stack applications. So that's basic. But beyond that, you have full user management with email-based password recovery. We have role-based access control and permissions for certain endpoints and not for others. We have admin roles. We have recruiter roles, and so on and so forth. We have real emails sent to real people. We have credit card checkout with integration with Stripe, just like any new startup would do. We have incremental loading and pagination. We have backend filters. We have markdown rendering on the front end. We have image compression on both the front end and the back end. A lot of features. And this was built all with Scala 3 and the Typelevel stack. So I would like to talk about the kind of architectural decisions that went into this application, none of which were obvious at the time of writing, and maybe you'll get some kind of lessons that you can take to your day-to-day, and maybe you'll want to try this app, or maybe you want to take the learning experience that I've created to build this app. You can build it with the Typelevel rite of passage, which I have recently created. So the stack is full on Cats effect and friends. So I use Cats and for functional programming and extensions and general niceties and validation and capabilities. We use Cats effect for pretty much everything else. So every action that you perform there is based on Cats effect. We use Doobie for databases. We use HTTP4S for server APIs and for authentication and authorization with a little bit of magic that we went and extended there. We have many other Typelevel libraries for the backend. So we have pure config for configuration. We have log for cats. We have some FS2 for incremental loading. We have Circe for JSON. We have Cats effect, wrapping, test containers, which is pretty cool because you can test pretty much live instance of this application using test containers instead of a real database. So we have a lot of the Typelevel ecosystem in the backend. On the front end, we have Tyrian, which is a new library based on Cats effect and FS2. I don't think Tyrian is an official Typelevel library, but it's entirely based on Cats effect. And this is very powerful. I'm going to talk about the architectural decisions of this front-end application. It's been built in Scala.js with this library, and maybe you'll get to use this stack for your own application. So I'm going to bore you with some slides first with the architectural stuff. I won't take too long of your time. So the architecture of this app is kind of a mix between an onion architecture and a hex architecture. It's mostly an onion, but with a couple of features of hex. So I called it Onion X. I don't know if this is a thing, but I just call it that way. So the way that this application works is that we have some domain model at the center. This is the root of the application. On top of that domain, we then create a little core, which is the green circle that you see on the diagram. That green circle means the fundamental operations that you can do with these data structures. For example, when you want to find a user by a certain ID, that may interact with the database, that may look the user in a cache, or the implementation doesn't matter, but the repository or the core that you see in the green circle on the diagram means the fundamental smallest operations that you can perform. Now, on top of those, you can create a mini flows, something like the user would use. For example, the user wants to log in. Now, in order to do the login, you need to find whether the user exists in your database. Okay, if it exists or not, then you get an error. If the user wants to add their password, you have to validate the password. So these kind of mini operations built into the service layer, which you can see in the orange circle over there. And on top of that, you have a full-blown experience. For example, the UI is a single experience because the application is a single-page app. Or you may want to provide a testing infrastructure. Or you may want to offer an API for a bigger job board that you would integrate your own. So you would have these sort of building blocks that build on top of one another in a layered fashion. Now, this has some features of Hex that I'm going to talk about a little, but not much. It misses the ceremony of Hex with adapters and whatnot. But I would like to talk about the onion thing and why it's so great. So from the point of view of the user, you can replace top-level layers of the onion. For example, if the user wants to log in, take a look at the slice of the pizza there. The yellow slice of the pizza says the user wants to log in, which then builds up on the fundamental operations underneath. But you can replace that with some testing infrastructure, and the layers underneath work exactly the same. Or if you want to expose that API key to some other bigger platform, you would do that too. You would also be able to peel off the layers of the onion and then replace the underneath ones with some other things. For example, if you want to test this application full stack, you would replace the top-level layer and just replace the orange one with testing the core modules. So you can do that. It's very easy for the onion. The onion itself, or rather the core elements, the innermost circles of the onion, may not necessarily exist. For example, for the credit card checkout, I don't have a domain model specifically for that because I'm only interacting with Stripe. I don't really need to model that credit card checkout myself. I just call some APIs from Stripe, and they come back to me. So the onion has some layers missing depending on the kind of operations that you want to perform. Now, in terms of Hex, the hexagonal architecture, I have no idea why it's called a hexagonal architecture, to be honest, why the hexagon and whatnot, but I'll skip that. The hexagonal architecture means that you have a business logic that is separated from the server side and the user side. And the business logic stays intact regardless of how those things are implemented. Okay. The application has this sort of feature in the sense that the UI and the server side can interact with the business model, and the way that the user tries to perform some sort of action will go through the core logic and then to the actual implementation through inversion of control. And we have a few patterns in the actual code of the application. I'm happy to give you a little demo after the talk that will allow the user to perform what they would actually normally would, for example, to post a job once they're logged in or not. Now, the backend itself has this OnionX architecture written with the CATSFX style in tagless final. So tagless final is a way of describing computations in terms of expressions that are only compilable for some types and not for others. So this thing is generally misunderstood to be entirely type class dependent, but type classes are just the way that tagless final is enabled for the lack of a better word. So the layers are described in terms of their capabilities with cats or cats effect type classes, and the programs themselves, which is the core business logic of the application, they're described in very general terms. Now, when you want to actually run the program, you will plug in an interpreter, which is an effect type that has all these type classes implemented, and then this will start performing some real things in the real world. So this is an example of one of the core layers of that. This is one of the slices of the pizza, by the way. This is my actual API for logging in for the authentication module of the application. So you have the fundamental operations like logging in, signing up, changing password, recovery tokens, and whatnot. These are the actual APIs that I'm using in the application. Now, when you actually build or instantiate this thing, you would pass the sort of type class dependencies there for the effect type. So the effect type needs to have some sort of capabilities to be able to perform certain effects. For example, if you're using monad cancel in cat's effect, then that means that the effect that you're running is cancelable or not. So you can click cancel there so that you don't waste computational resources. And this takes explicit dependencies, and then you would build an instance of that slice of pizza using the effect type. So this will actually power up the engines. Now, tagless final works nice for a variety of reasons. If you organize your code with this slices of pizza kind of organization with tagless final, you will get some nice benefits. For example, the layers will click very, very nicely. If you take a look at the for comprehension in there, it's super clear what everything does. If you want to build the core, the entire layer of the application, you know for a fact that you need a module for jobs, a module for users, a module for recovery tokens, a module for emails, a module for authentication, a module for Stripe, and you're done. So it's super clear what means what and how these pieces click together. Each layer will have its own capabilities described by the type classes. So some slices of pizza will have just cancelable effects, but some slices of pizza might be more powerful, that requires a more powerful type class, for example, concurrent in cat's effect. So these things will have their own sets of capabilities, and when they're brought together, the stronger type class will win. Now, this is also easy to configure because when you create a configuration for the entire application, that configuration mimics or rather replicates or maps identically to how the slices of pizza are being created. So you know for a fact that the large configuration for the app has a configuration for jobs, for users, for tokens, for emails, for authentication, or for Stripe as necessary. And you know what kind of piece of configuration to pass to which module. So it's super clear how you should configure your application as well. It's also easy to test and replace individual layers because you can very easily swap the users module with some mocked users module, and the thing still works. It's also very easy to navigate because once you take a look at this for comprehension, it immediately becomes apparent what kind of module does what, so that if you want to add some sort of functionality, you know where to look and where to modify. It's also easy to read and maintain, also powered by Scala in general, because Scala is such a compact and nice language to read and understand. But it's not all roses and butterflies. The tagless final pattern requires some discipline, as Adam also said. So it requires a certain learning curve and a certain level of knowledge beforehand. So for example, you have to know the power of every single type class in cat's effect so that you know which one to use for each module. Because when you end up writing async on all the type classes, well, it doesn't really matter whether you're using tagless final or not. It's actually quite detrimental because once you use the strongest type class on every module, you're essentially calling I/O. The only type class that implements async is I/O or ZO or what. You're basically just stuck with these. So if you want to use this pattern, try to learn what kind of power each type class in cat's effect will give you. Also, errors are quite invisible unless you surface them manually. So from the point of view of the HTTP server, you're writing your business logic just fine, but when the HTTP server gives you a 500, you have no idea where that error comes from. So you have to surface those out and log things very disciplined and manually in order to figure out where things went wrong. So you have to be very disciplined with error handling as well if you want to trace and debug your code nice and clean. Now, one drawback with tagless final, especially as you build a larger application, is that when you build your modules together, you'll almost always end up with the strongest type class. Because if you have a slice of pizza using monad cancel, if you have a slice of pizza using concurrent, and if you have a slice of pizza that uses sync, then you're stuck with async for the entire layer. And async is the strongest type class in Cat's effect, which means that ultimately you're stuck with I/O at the very end. That's not necessarily a problem for the individual layers because you know the power of every individual layer in turn, but at the very end you end up with async. And if you end up with async too soon in your application, then it's very easy to get stuck for 50% of the code base in your application with async and tagless final, and at that point it starts to lose its value. Tagless final also becomes very tempting to misunderstand because the tagless final style with Cat's effect relies on passing implicit type class dependencies in there, like colon async, colon logger, colon encoder, decoder, and that sort of thing. And becomes very tempting to pass all these modules or all these slices of pizza as implicit dependencies instead of explicit dependencies. So you end up with something like this, where you have all these type class dependencies with the core modules passed as type bounds instead of explicit dependencies. So this is an anti-pattern that you definitely should not use, but once you think you've learned tagless final, you start to pass all these things as implicit dependencies, and that does more harm than good. It also hurts your compilation times, by the way. So don't do that. So in general, if you want to use this pattern, you have to be quite disciplined about it, and you have to kind of know what you're doing, which, as Adam previously said, this may constitute a higher barrier for entry. So this was the backend with this onion next kind of architecture and tagless final. On the front end, we have Scala.js, and Scala.js is pretty vanilla wrapper over the JavaScript libraries, but for the single-page application, we're using Tyrian. Tyrian is a small little library that's built or inspired by the Elm programming language, and it's written almost entirely with Cat's effect 3, and this works best for single-page applications. The way that Tyrian is built allows you to run your applications with pure functional programming, so you have state update. I'm going to talk about the Tyrian core principles. You have decoupled state management and message-based updates, so asynchronous, almost Akka-style kind of message passing between components so that the core application can handle them. I'm going to explain how that works. If Tyrian is foreign to you, I'm going to explain, and it will make sense, I promise. And it has a built-in HTTP client, which means that we can interact with the backend quite easily with the same style, like message passing asynchronously. And we can run Cat's effect style effects. I have a little moment that I'm quite proud of. I'm using Cat's effect async to do image compression on the front end, wrapping the core JavaScript library. I'm going to show you. So the way that Tyrian works is that the application has a model or the kind of data that you're remembering to render on screen, and it can receive messages in a non-blocking way. And every interaction, for example, when you click a button, for example, when you send an HTTP request, that will send a message that will then later be handled by the application. And the way that it's being handled is that based on the current model that you have, plus the message that you receive, you obtain a new model. And with that model, you can go re-render the page. That's the general principle, and the cycle begins again. So what you see here on the screen is kind of like the simplest application that you can write on Tyrian. It seems like a lot of code, but I'm going to deconstruct it bit by bit. So a Tyrian application has a model, which is the state of the entire application. For example, the kind of filters that you have on the jobs board. For example, if you're checking remote jobs for salary at least $1,000, and in countries like the United States or Poland. That's the kind of information that you would store in the model. And then you have messages, which are pieces of data that are going to be handled based on which you can then update the model. And these messages can contain information. For example, I've just logged in as Daniel@rockthejvm.com. I have a little message that says user logged in with that email, for example. So these messages can be sent by a variety of things in Tyrian. They can be sent by a command through a pure command.emit, which will then later be handled by the application. A subscription, which is an FS2 style stream that will emit messages every once in a while, depending on how your application logic is being built. I'm using subscriptions, by the way, to listen for history changes in the browser so that it feels like a single-page application. So when you do back and forward in the browser, those are FS2 events that are then listened to and update the state of the page. They can be triggered by an interaction. For example, when you click a button, so when you say button on click, that actually sends a message that the application will later handle, and then we'll do the re-rendering bit. So commands are, in general, an action that will result in a message. And a command is kind of a wrapper for a cats effect I/O, and it will. There are various types of commands. You can emit a pure message, so command.emit that you see here at the top of the screen. You can perform an arbitrary side effect, really. So an arbitrary I/O that results in a value. That value, when the I/O is being completed, will be handled by the app. You can also send a message by running some non-blocking operation, like sending an HTTP call to the backend. Or you can combine multiple commands together with semi-group-like notation, and I'm going to show you how we use semi-groups in the app. So these are the general concepts: models, messages, commands. Now, the core functions that a Tyrian app needs to have is init, which builds the initial model of the app, and the initial command that the app will run. For example, if you load the page, you'll have basically 0 data, but the first command is going to be, give me all the jobs in the backend. But that command is an HTTP call, which will then return at some point, and you'll end up displaying the jobs. So it's kind of like the bootstrap action in the entire application. Then you have the update, which is probably the most important thing, which is a state change. The update function takes a model and a message and returns a new model. So it's a regular state change, but Tyrian will also have a little twist, because you see there that the function returns the tuple, in which the first member is the model, and the second member is a new command. For example, when you update the login, or maybe you forgot your password. If you forgot your password, then this issues a command that will then trigger an email to the user. So it not only updates the model in the application, but it will also send a new command. Maybe you want to update the application later if something went wrong. Then you have subscriptions, which are FS2-style event streams that you can then listen to, and those are being handled by the update function for every single element in that stream. And then you have the view, which is a completely separate function, and that's the pure function that, based on the model, you render the page. So you have the model, view, and then you have something in between, which is the view model. I'm going to talk about the scalability of the application. So how do you scale this sort of thing? This application looks like a lot of code when you're seeing it for the first time. And as you build a larger application, this code may become a little unwieldy if you are writing all the code in one place. So you have to break it down into components that have their own state. But how do you update their own state? You have to break down the model of the application as well into the constituent parts that you are then going to render on screen. For example, in the job page, in the application, you have a filter panel that has its own state and a jobs list that has its own state. So the model of the page will consist of the state of the filter panel and the state of the job list. And those states are being handled independently, and you can send messages to, or rather handle them, in every component in turn. So you should keep your message types in the companion objects of the classes that represent the components that you want to render on the screen. And Scala 3 is actually very great at using traits and enums and union types to design your messages. So that's is very reminiscent of Akka back in the day. So you'll have one application with these functions that you see on the screen, but every component has, or will have, its own model and its own view function. So the app is going to be the place where you'll intercept all the messages, and then it's your job to reroute those messages to the component that's responsible for them. For example, in the filter panel, while you're building up your filters, for example, remote jobs, when you're clicking that checkbox emits a message that will be handled in the main application, and in the main application, it's your job to forward that message to the correct component that is going to be updated from there, so that you can actually end up rendering the goddamn checkbox that's just being clicked. So this essentially replicates the model in the application and in the constituent components, and the model becomes the thing that's being rendered on screen, which means that you have a model, view, and then a view model in between. So this is the kind of pattern that you end up with if you want to scale your application, and this is the pattern that we're using throughout the jobs platform as well. Now, I'd like to take a few minutes to talk about some memorable moments that I had while writing this application. And one instance is using math to actually build useful things. For example, semigroups in real life, it becomes beautiful to compose HTTP endpoints and by authenticated or not authenticated endpoints just by using pluses. And you can store these endpoints or organize them in any way that you see fit. I love this sort of thing. I'm not sure if you do, but this makes it super clear to me what endpoint means what and how you can stitch them together. So semigroups in real life. Another kind of memorable moment for me was the fact that pure config just uses type class derivation to implement, or rather create, implicit type class instances for me instead of having me write them manually. So I think we all have experience with Scala libraries where you have to write your own implicit encoders, decoders, serializers, and so on and so forth. But these things just work. You say, create a case class, derives config reader, which you can see there at the middle of the screen, and boom, it works. Just say config source load your type, and then you're done. You can pass the fields of your case class to the respective layers of the pizza that I was talking about. So this is pretty cool. I'd like to see this more in Scala libraries. Another one is to purify Java APIs. So for sending emails, I'm using the plain old JavaX mail packages, but wrapping them in resources feels beautiful to me, and it feels that we brought them to another level in the style of the same application. So we have these 4 comprehensions with resources, and it works very, very nicely. Another one is one of my proudest moments, which is using io.async to compress an image on the front end. So on the screen, this might seem a little convoluted, but the first 3 lines of code, they're the most powerful, really. So you have 2 solutions of the world's problems. We have traverse and we have async. They're in one go. And after that, after the async, there's just the JavaScript API. So most of the screen is just the JavaScript API, basically wrapped in Scala.js. But async is so powerful because you can fulfill your I/O, you can fulfill your effect at any point you want, and then you can run arbitrary code inside, for example, the JavaScript asynchronous code, which is pretty much how you write JavaScript, with callbacks. So that middle of the screen is callback hell, but I try to wrap it around so that when you end up with is a message that the app later intercepts saying, hey, the user has just uploaded a logo for their company when they want to post a job. So any JavaScript action is lifted into I/O, and the result of I/O is a message that the application later handles. And this obviously triggers a front-end update, and this also happens in single-threaded JavaScript with Cat's effect, which is very, very powerful. And here I have what you're going to see next is I almost threw a party after this one. So this is the checkout flow when the user actually fills in their credit card, and I chased a little flag in the database. So the active job is that true flag. So that true flag, I worked for a week to get that working with Stripe. That true flag means that the job is active, and then you can see it on the front end. So I built probably my biggest project, not probably, 3x bigger project at Rock the JVM. I called this the Typelevel Rite of Passage. This is the course that is going to teach you how to build this app with the architecture decisions that you just saw. So this is a product-based course in Scala 3 where you can build this exact job platform with these exact features, including credit card checkout and whatnot. So I think this is my best work yet. And I have to thank some people there. I have to thank my former student, Ricardo, for prototyping what became a good chunk of the backend. Dave Smith from Tyrian for merging my PR that allows me to render Markdown on screen. And the artist Fellow Noodle for creating this banner. So thank you for coming to my talk. I hope you'll enjoy the course and using the application. Thank you very much. I'm happy to take any questions.
Okay, Daniel, thank you very much. I like that your name is Daniel and nothing more tricky.
Yeah.
Okay, do you have any more questions for Daniel? Yes, let's ask them.
Thanks for a great presentation, Daniel. I wanted to ask you, do you have any tips for not ending up with these powerful constraints in your code base?
For the powerful constraints, well, it's kind of the fact of the world that you have to use some functions and not others. For example, if you want to run SQL queries in your database, you'll have to use concurrent for that. For example, there's no way around them. So the tips are always use the least powerful type class always, and whatever you end up with is whatever you end up with. But there's nothing more than you can do than know the power of each type class and use the least powerful one every time.
Hi, Daniel. I have a follow-up question regarding tagless final. In the Scala JS example, you were dealing directly with I/O. Mm-hmm. And I'm just wondering, could you name some benefits of using tagless final instead of using I/O directly, which is the case in the end, in the final app, either way?
So the question is, why should we not just use I/O everywhere? You can use I/O everywhere. There's definitely no need for tagless final in an app like this. So you can just use I/O everywhere. But if you want to be very clear about which core module or which slice of the pizza does what, instead of providing the most powerful effect directly, you should use this sort of pattern.
Okay, anyone else?
Hi, I have a follow-up question. So if there is no need to use tagless final instead of I/O in this kind of application, where is the need?
Where's the need? There's
for
no
tagless final.
Yeah, there's no need to use tagless final if you find it's too burdensome or if it's too hard to make sense of all these type classes. Just use I/O everywhere. Just use resource, by the way. Resource is absolutely great in Cat's Effect. Just plug it everywhere. Resource is fantastic. Tagless final is used in this particular application in this course because I wanted to make it super clear what benefits a certain type class gives you and a certain power that that particular slice of pizza has. There's absolutely no real need to use tagless final, but then again, there's no real need to use, Scala.
Okay, one more question. Which testing library did you use and why?
Say again?
Which testing library did you use?
Testing library. I used Cat's Effect testing, wrapping test containers.
So this is the module for Scala test, right?
Yes.
Okay.
So Scala test, yeah.